Hello everyone, myself Munaz Reza and I am going to record today's session. So first of all, we search remote desktop connection and we will type this IP address, that is 10.0.26.165. Then on clicking connect, this window will open and then the Linux terminal will open. So as you can see that this is the Linux terminal, and we will create a new folder, that is I am going to name this as an assignment. So I will rename this file name assignment, and I will open this folder and then I will open in terminal. Then I have to type this command csh, then source home cadence csrc, and then I will type virtuoso and space ampersand. Then cadence will open and it is taking some times, and as we see can that the cadence has been opened, and then on clicking file, new file and library, in this time I am creating new library and I am naming this library as inverter inverter inverter, and on clicking attach existing technology library and then okay, apply, and this window will open up in which shows attached library to technology node. In this windows I have to select the library, and I am selecting gpdk 090 nanometer technology file, and I am applying this and then okay, and I'm closing this. As we see that our file has been created and technology node gpdk 090 has been attached. Then I will go new and then cell view, and now I am drawing schematic of inverter. So I'm naming this as inverter 1. So inverter sch, and view type is schematic and type is schematic, and then okay, it will open new windows, and this shows the Virtuoso schematic editor L editing, and in this windows I am going to make schematic of inverter, and then in instance, and then browse, and I will select my library, and from this library I want select the MOSFET. So I can directly typing this MOSFET 1, and then MOSFET 1 is attached. Then hide this, and no GPDK MOS and MOS. Sorry, I have to 90, and in this NMOS 1, and as we can see that the length of transistor is 100 nanometer and width is 120 nanometer, and I will not change any parameters and then hide, and this is all my NMOS and I am placing this here, and then escape, and this by same I will select PMOS to browse, and type PMOS, enter, then this is in the PMOS, and again I will not change any values, and I will place this in here, and I will zoom it F, and so as we see that two transistor has been attached. Now I will make this schematic general, so I have to take create pin, and I am creating VDD, V in and VSS, and the direction is input, and now hide. I can see that the VDD has attached in my cursor, so I will place top here, and then VIN will be here and VSS will be here, and one more pin, that is V out, which will be attached here. So again create pin V out, this time direction will be output, and hide, and I will place it. Now the pin and transistor shown in schematic. Now I have to connect. So we will click on create narrow wire, and I will connect as shown in diagram. So for escape I will redo, and again wire connect to here, connect here, and this way body terminal will be here, and the gate will be connected, and then be out. So this completes our inverter, and now I will save this, save and check save. If any error occurred, then it will show, and we can also verify in here that the inverter schematic has been saved and no error, with no error. So our schematic has been created, and we can zoom it. And now I will create a block diagram. So create and cell view, from cell view, and inverter schematic I will read as it is same. Okay. And the block diagram that will be created has 4 pin, left pin, so left pin will be VIN, and right pin will be Vout. Okay, top pin will be VDD, that is supply, and the bottom pin is ground, so I am naming VSS. And okay, so as I can see that this is a block diagram of inverter, and we can change the name, the part name will text editor and inverter inverter. And we can also change this. So I am going to change this, will I am going to create this, and I will create a triangle. So for do that I will create shape, and in I am going to line. So I am creating line this, and I am making triangle. So this way I can make this, and I have to take one circle. So create shape and then circle, and I will make the circle here, this way. Then escape. As I'm seeing that, so I will, okay, I can also delete this. So now I have to realign the pin, so I can select this whole things, and so now I will replace this, undo, undo. So I can this, and same I will do this, overlap. Okay, so this is VDD, I can place it here, and this is VSS, I can place it here, and this is VIN, and I have to realign this, and then Vout will be here. So I am seeing that the connection has been done, and the inverter is, symbol has been drawn. So now I will save this and check save, and I can see that there is no error. So our schematic has been created, and then again we will go to file, and then new, and then cell view. Now I am going to test the schematic, so I will rename as inverter schematic TV, and then okay. Then I will call the schematic that I have created earlier. So from instance browse, and the library name, so I have name inverter. So I am not finding inverter right now. So again I will cut here. So this is a old, I have to delete it. cell view new. So I have selected my library inverter already. Okay, okay, yes. So I will call this browse. Sorry, I have to inverter and inverter. The top was inverter and inverter schematic. As we can say that block diagram, and then okay, I will place it here. So now I have to apply the input and out input and VDD. So for instance, I will browse VDD analog library and type VDC, and the DC voltage 1.8. Okay, I will place it here, and again we have to apply input. So in this I will type V pulse, and the V pulse will be, the DC voltage will be 1.8, period 20 nanosecond, delay 0, rise time 1 nanosecond, pause time 1 nanosecond, pulse speed 10 nanosecond. Okay, I will place it here, and then I have to apply ground. So again at instance browse, type here ground GND. So and I will place here, here and here. Then I have to create pin name. So we have V out, output V out, and I will place this here. Then I will VIN and input, and then I will place it here, and then I will do connections with wire. So connection will be done like here. Here to here. Right now I'm getting error. I'm going to delete this. So undo, delete this. I have to create it outside. So V out is output, and I will place it here, and then I will connect this. Okay, and I will connect this, and as we can see, the our connection has been done. So I will save this and check save, and I am saying no error. I can verify from here with no error here. Then this is the order, and this is, and then I have to apply the ADA, and we will go launch ADE, and then I will do transient analysis, and the stop time is 100 nanosecond, 100 nanosecond, and moderate, apply, then DC, save DC point, select parameter. I will select from component this, and I will select VDC. Okay, and I can see that is from start to stop 1.8. Then okay, as I can say that the analysis has been done, and I have to take the v out output. So from this output we plotted, and I have to plot output as the input. So output is this and input is this. As we can see that the v out and v in pin has been created, and then we'll hit, yeah, run button. So as we can see that we got error. So this error can be bypassed by saving all the states, and now I'm going to know. As I can see that our inverter symbol has been created, and now I will log out and again reopen this. That time it will be run. So I'm exiting. I will type exit here. So and again exit, again exit. So all has been cut, and then I will log out. Now there is a log out. So let's say log out. So as we can see that I have log out from the that windows, and again I will log in remote desktop, and again connect. Yes, again I come in this Linux version, and I'm opening my folder assignment, and then open in terminal. Then I will type csh source, and then cadence virtuoso %. So cadence has been opened, and now I will reopen my file. So open, I have select my library inverter, and I'm going to test bench. Then okay, then it will reopen my work that I have done last few minutes, and then I will launch ADL. Again I have to redo that things. Transient 100 nanosecond, moderate, apply, then select DC, save, component parameters, select DC, which I have to sweep. Okay, and and I have to do right start and stop time. So I'm sweeping 0 to 1.8, and I have to select the output. So I will go output to be plotted, select on design, and input or output will be level. So as I can see that the output has been V out, V in, and LSS are transient and DC. Then I will run this. So as I can see that this our LSS has been run, and the I will separate it, and as I can see that this is a VIN. So and this is V out, and as we can show that the V in and V out are opposite. So this means that when VIN is VDD and V out is 0. And in the second graph, yeah, we can saw this is the VTC, voltage transfer characteristics. As the VIN grows up, and the VI and this is the V out. So this we have read in our textbook. So this complete the first session, that is the drawing schematic and applying input by using iterating symbol. So now I'm going to stop here, and I will record the next session.